Good morning, CP Pre-Calc. All right, guys, what we're going to do today is we're going to continue solving trig equations, but we're going to actually be utilizing our calculator a little today. So I just want to go over something with you real quick, and we talked about it when we were graphing trig functions. Now, the only trig functions we graphed were sine and cosine, so we're going to start by looking at them first. So just to be aware, I have my mode of my calculator in radians, so we can take a look at it. And we graphed our trig functions, and we moved and translated all our graphs, but if I just graph the basic sine x, which we talked about the shape of a basic sine function. If I graph it, my basic sine function looks something like this. All right, I'm going to open my window just a little more, so I'm going to open it to, I'm going to leave that as that. So 4 and 4. So this is our basic sine function, and we talked about it. And it's a sine wave almost, and the same pattern continues in a basic sine function every 2 pi, which is fine. But what I want to talk about is when we looked at our sine function, and I can keep on zooming this out if I want to. All right, if I zoom it out, it really looked like this. It was just something the pattern kept on going forever and ever in both directions. But we noticed that there was a max and a min. All right, so there was a restriction on what sine theta could be. So if you had your basic sine function looking at this, and I took it, we have a max and a min. And if we recall, the max of our sine, and we talked about this when we were graphing our trig functions, the max of our basic sine function was 1 and the min was -1. So we want to just remember. So we're going to recall that sine theta has to be between 1 and -1. All right? Now that same thing applies here if I look at, say, we said cosine theta. Cosine theta looks similar to sine theta, except it was just translated in one direction. And we looked at cosine theta, and cosine didn't intersect our x-axis at 0. It began at 1 on our x-axis, but it still followed that period of having, we had a period of 2 pi, where it kept on repeating itself in our basic cosine function. But again, our max of cosine was 1 and our min of cosine was -1. So I just want to emphasize that. Now tangent, we did not graph, but I want you to just take a look at what the tangent graph would look like for a second. So just so you understand something, the tangent does not have a min or max. All right, but the tangent does have an infinite amount of asymptotes. All right, so the tangent does not have a min or max, but it will have x values where it is undefined. So in this case, this is the graph of a tangent, and you'll notice in a tangent has no min or max, but does not exist when, what happens, guys? When we think about it, tangent of theta equals what? Y over x does not exist when x equals 0. Tangent of theta will not exist when x equals 0. All right, so we need to know this. Sine has to be between -1 and 1. Cosine has to be between -1 and 1. And tangent does not exist when x is equivalent to 0. All right, that's what I want us to recall right now. All right, the tangent stuff's new, but I want to recall these two concepts. All right, guys, so let's take a look at a couple of problems. Okay, the first thing was kind of somewhat of a review from yesterday. I'm going to give you sine squared theta minus 2 sine theta plus 3 equals 0. All right. Actually, I'm sorry, minus 3. It should be minus 3 equals 0. I'm sorry. So let's factor this, guys. That should have been minus 3 equals 0. If we want to factor this, we're going back to saying what, in this case, adds to -2 and multiplies to -3. So we're taking a look at those two values. So we have this -2 and this -3. And we know what adds to -2, multiplies to -3. We know it's going to be, in this case, sine theta will be, if I look at it, adds to it should be -3 and 1 multiplies to -3. -3 plus 1 adds to -2. So it's going to be sine theta minus 3 and sine theta plus 1. All right, guys? Now, if we take a look at this and we have these values, here I would have sine theta minus 3 is equivalent to 0. And here I would have sine theta plus 1 is equivalent to 0. Now, let's solve this. If I solve this, here I'm going to get sine theta equals 3. And here I'm going to get sine theta is equivalent to negative 1. Well, if we look at our unit circle, sine theta is equivalent to negative 1 at one value. It is equivalent to negative 1 at 3 pi over 2, because that's when my y value is equivalent to negative 1 on my unit circle. What about over here? Sine theta equals 3. What did we say sine has to be between? Sine has to be between a negative and 1. Can sine theta ever be equivalent to 3? No, this does not exist. Sine theta must be between negative 1 and 1. If you get a value for sine that is not between negative 1 and 1, that answer does not exist. The same applies for cosine. If you get a value of cosine that is not between negative 1 and 1, then it does not exist. All right, guys? All right, so we're going to take it a little further here. And I'm going to give you another example. And my other example is going to be 2 cosine squared theta plus 2 cosine theta minus 1 equals 0. Now we have to factor this. Now this one's slightly different because we have a 2 in front. So let's try our method. We're going to take 2 and we're going to multiply it by negative 1 to get a negative 2. And we're going to say what adds to positive 2 and multiplies to negative 2. Is there anything that does that? Is there anything that adds to positive 2 and multiplies to negative 2? No, not that I know of, because the only thing I can think of that adds to positive 2 would be 1 and 1. But 1 times 1 does not equal negative 2. So this means that this is not factorable. However, when we learned about quadratic equations in the past, if something wasn't factorable, we went to our quadratic formula. So that same knowledge will apply here. So we're going to go to our quadratic formula. And let's see. Remember our quadratic formula. If you have something in the form of ax squared plus bx plus c equals 0, we know that x is equivalent to negative b plus or minus the square root of b squared minus 4ac all over 2a. Sorry, guys. All right, so let's plug in our values. But the only difference here is instead of having the x equal here, instead of x, we're going to have cosine equals those values. So you're going to have cosine of theta is equivalent to negative b, which would be negative 2, because b is 2, plus or minus b squared, which would be 4, minus 4, times a, which is again 2, times c. I'll put the 2 in just so you can see where everything is coming from. C, which is negative 1, all over 2 times a, which is 2. Now remember, when we simplify this, I need you to simplify under the radical first. And I also like, and I didn't put it here, but I should have, I also like to keep that 2 in parentheses. Here it didn't matter because it was positive, but it does matter if it's negative. So if I do this, I simplify under my radical first. And if you simplify under your radical, you're going to get 4 minus a negative 8, which will be a positive 12. So you're getting negative 2 plus or minus the square root of 12 over 4. Now, wait a minute. I do not see anything with a plus or minus or a 2 plus root 12 or any of that on my unit circle. Well, we're not going to use our unit circle for examples like this. We are going to use our calculators. And in our calculators, we want to be, again, in radian mode. So I'm going to accept your answers in radians. So make sure, again, we just looked at it, our calculator, go to mode, make sure radians is highlighted. And if I do this in radians, what I'm going to first do is I'm going to evaluate what cosine would be. All right, guys, so I'm going to look, I'm just going to carry this over here so I can go down. All right, so you see it. I'm going to look what cosine can be. So if I look at what cosine can be, cosine of theta is approximately, let's put this in our calculator. All right, so we have, actually I'll break it up into two first. Cosine of theta will be -2 plus the square root of 12 over 4, and cosine of theta will be -2 minus the square root of 12 over 4. All right, guys, so let's take a look how we do that. Let's put that in our calculator. And if you put that in your calculator, you're getting -2, put your numerator in parentheses, plus the square root of 12, close the parentheses, the entire numerator goes in parentheses, divided by 4. That will be approximately, let's round to 3 decimal places, cosine of theta will be approximately, especially in radians, 0.366. Now let's see what cosine theta is over here. Now over here, I'm going to be doing -2 minus, again in parentheses, my entire numerator should be in parentheses, and then divide it by that denominator. Cosine of theta should be approximately -1.366. Now what we're going to do here is we're going to find our value of cosine, find our value of theta. I'm not going to find these two values on my unit circle. I'm going to actually use the inverse trig functions on my calculator. So remember, inverse trig functions. So we are going to utilize our inverse trig functions. And how do we use them? We do second and then the trig function. So if I look at this, I'm going to say, if I want to find theta, I'm going to do the theta, it will be equivalent to, I'm going to write it down first, the inverse cosine of 0.366. Here, theta will be equivalent to the inverse cosine of -1.366. So now let's put that in our calculator. So I'm going to do second cosine, which gives me inverse cosine, 0.366. Now it's going to give me my answer in radians. And my first answer would be theta is 1.196, everything to 3 decimal places. So here, theta, one of my answers is theta is 1.196, comma. My other answer, I'm going to do second cosine -1.366. And what's up? I got a domain error. So, what does that mean? Somebody explain why I got a domain error here. It's in this case, well, cosine, they're telling me here, it's telling me the cosine is approximately -1.366. Why do I know that can't be? Well, I know that cannot be because we stated here that cosine has to be between -1 and 1. This is outside what cosine is allowed to be. So in this case, this does not exist. And that's why we get an error on our calculator. So calculator kind of helps warn us there. All right? So now I have this one answer of 1.196. Now the question here is that my only answer? Now we have to think of a full revolution around our unit circle. So this is, if I have cosine and cosine is positive in 2 quadrants. All right? Now, if I think of this in 2 quadrants, here I have 1.196, right? So if I think of all students take calc, this 1.196 is going to be in quadrant 1. Because if we think of this, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. Let's think about what everything represents. Pi is approximately 3.14, right? Pi is approximately 3.14. That means pi over 2 is approximately 1.57. 3 pi over 2 is approximately going to be 4.71. I know this 1.196 is in quadrant 1. I need to have another cosine that's positive over here. Now remember, it's between 0 and 2 pi. So this is 0 and this is approximately 6.28. So to find it, if this is, watch this guys, if this is 1.196 in this direction, I need to do 1.196 here to find something with the same exact cosine value, because I know cosine is positive in quadrant 4. So I would take that 6.28 and I would subtract, because we're doing an estimate, 1.196. And you would get your second radian measure to be 5.084. I know that's probably a lot to take in. All right. Okay, guys, let's do one more together. All right, guys. So we're going to do one more together. Okay, let's take a look at our next one. Okay, let's do another one. We have our next one's going to be solve on the interval 0 to 2 pi. Now, again, I have tan squared theta plus tan theta minus 2 equals 0. Now, again, check if this one's factorable. We're going to do actually 2 more. So let's try if this is factorable, because some of them can be. Now, if I take a look, I have tan squared plus tan minus 2 equals 0. If I look at this, I'm going to say what adds to 1 and multiplies to negative 2. And in this case, it is factorable because I know I have a 2 and a negative 1. So if I take a look at this, I have a 2. So I have 2 times negative 1 is negative 2. 2 plus negative 1 is 1. So I can now rewrite this as tangent theta minus 1 and tangent theta plus 2. If it's factorable, please factor it. Now let's take a look at this, guys. All right, let's take a look at this. I have tangent theta. Now it equals 0. Tangent theta minus 1 and times the quantity of tangent theta plus 2 is equivalent to 0, the product. So I'm going to take both those values and set them equivalent to 0. Now, guys, when we solve this, I get tangent theta here is equivalent to 1. Here I'm getting tangent theta is equivalent to negative 2. Now, remember, tangent can be less than negative 1 and greater than 1. So this can exist. We have to check it out. Now, what we're going to do, guys, if you take a look at some cases, now we can see we can't always use the unit circle to help us out. In this case, I can. When is tangent of theta equivalent to 1? Now, if we think, remember, we're going to have to always remember to think about all students take calc, because I'm doing it on one revolution. 0 to 2 pi is always 1 revolution. All students take calc. I need to find a theta value. If theta is a positive 1 in quadrant 1 and quadrant 3. Now, tangent. In order for tangent of theta to be equivalent to 1, your x and your y values would have to be the same. So, because tangent theta is equivalent to y over x. So, if you look in quadrant 1 on your unit circle, theta would be pi over 4, because both x and y are root 2 over 2. If you look at tangent of theta being 1 on your unit circle in quadrant 3, you're going to know, again, the reason in this case it's going to be 5 pi over 4, because both x and y are negative root 2 over 2. So those I was able to use my unit circles to find. However, here, I cannot use my unit circle to find when tangent theta is equivalent to negative 2. All right, so if I look at my unit circle, I cannot find tangent theta is equivalent to -2. So I'm going to have to utilize my calculator. And remember, I want your calculator in radian measurements. So in order to find theta here, I'm going to do theta is equivalent to the inverse tan of -2. Now, when is tangent negative? I need to find a measurement in quadrant 2 and in quadrant 4. So let's take a look at that. If I go to my calculator, I'm going to do second tan -2. Now it's only giving me one answer. All right, guys? And it's giving me a negative answer. And that negative answer is not between 0 and 2 pi. So in order to find the positive answer here, what you're going to have to do is add that revolution of 2 pi. If I add that revolution, I'm getting this to be approximately 5.176. Now if I look at that, what quadrant would that be in? That would be in quadrant 4, between 6.28, right? So we know that is between, if we looked at what I wrote on my other page, I had 6.28, I had 4.71 down here, approximately. I had 3.14, which we knew, and I had 1.57. Those are approximations. I know 5.176 is in quadrant 4. However, tan is also negative in quadrant 2. Now, how do I figure that out? That means that value, see this value of 1.170, I now need to subtract it. I subtracted it from 6.28 to find quadrant 4. I now have to take that away from 3.14. So I have 3.14 minus that 1.107, and I'm going to get that to be, theta to be approximately, this is an approximation, so I'm putting squigglies, 2.033. So I would have these would be exact solutions that I was able to find, and these would be approximations. But all 4 of them would be solutions to my equation. All right, and that worked out nice that I was able to factor that. All right. All right, guys, let's try one more with that quadratic equation. All right, so this is our last